Assalamu alaikum students. So today we are going to start the preparation for the quiz competition, and the subject is chemistry 507002 unit 1, and the chapters included redox reaction and electrolysis. So start with the name of Allah. Bismillahir Rahmanir Rahim. Question number 1, what is meant by the term redox? So redox is actually divided into the two terms. The one is red and the second one is ox. So red mean reduction and ox mean oxidation. So reactions which involve both oxidation and reduction called as redox reaction. Question number 2, define oxidation and reduction in terms of loss and the gain of oxygen. So as we have studied that gain of oxygen is called oxidation. So in the reaction you can see the carbon monoxide gained oxygen from iron oxide and become carbon dioxide. So it means that gain of oxygen by carbon monoxide and forming carbon dioxide is the process oxidation, and carbon monoxide is oxidized to carbon dioxide. Then loss of oxygen is called as reduction. So here you can see that iron oxide lose oxygen, and this loss of oxygen is called as reduction. So iron is changed from iron oxide to iron. Question number 3, define oxidation and reduction in terms of loss and gain of hydrogen. So gain of hydrogen is called as reduction and loss of hydrogen is called as oxidation. So some of the examples are given. You can see ammonia react with bromine gas and forming hydrogen bromide. So this is like bromine gained hydrogen and gain of hydrogen is reduction. In second one you can see ammonia is the loss of hydrogen where occurring ammonia by losing hydrogen and converting into nitrogen gas. So this process is called as oxidation. Define oxidation and reduction in terms of loss and gain of electron. So here you can see the loss of electron is called oxidation and gain of electron is called reduction. Loss of electron, you can see sodium is converted from sodium zero oxidation state. Here you can see in solid form. So it changes from 0 to here +1 by losing 2 electron. Fine. And the gain of electron in the other reaction, you can see here the chlorine from its zero oxidation state it turned into -1 by gaining 2 electron. So it means that the gain of electron is called reduction and the loss of electron is called oxidation. Here oxidation and reduction in terms of oxidation state, increase in oxidation state called oxidation and decrease in oxidation state called reduction. So here you can see that magnesium from its zero oxidation state turned into Mg+2, magnesium 2 positive by losing electron. So by losing 2 electron it become Mg2 positive, and this is called oxidation, increase of oxidation number or the loss of electron which you have seen on the previous slide. Then here you can see copper from positive to oxidation state changes into 0, copper 0, and this is reduction. Decrease in oxidation state or in second gain of electron is also called as reduction. Decrease of oxidation state. Next is oxidizing and reducing agent. So you have learned about the oxidizing and reducing agent, that oxidizing agent is the agent which oxidized other and reduce itself is called oxidizing agent, and reducing agent which reduce others and oxidize itself is called as reducing agent. So here are some tests which you can see. The first one you can use the test where whenever you are add aqueous potassium iodide into any unknown solution, if its color turn into brown, it means that due to iodine presence by any oxidizing agent, it turned into brown color. So this is the test for oxidizing agents. Here you can see in the explanation it's given that iodide ion are oxidized to iodine by the oxidizing agent. So test for reducing agent, the other one you can see here, if you are adding aqueous potassium permanganate, the color change will be into purple, and the result if the chemical being tested is not a reducing agent, so you can see the color change, and the purple acidified potassium permanganate changes to colorless, and this is the result if the chemical being tested is a reducing agent. agent. So these are the tests for oxidizing and reducing agent. Now we are going to start electrolysis, the next chapter, and we are done with what were the electrodes, electrolytes. So here you can see the metal rod which are dipped into the electrolyte solution is called as electrolyte. Here you can see these two electrodes which are connected with the battery are called as electrode, and they are named as cathode and anode. Fine, the positive one is anode and the negative one is cathode, and connected to the positive and the negative terminal of the battery respectively. So here the anode positive electrode and cathode negative electrode in the electrolysis cell. What is electrolyte? Is an ionic compound in the aqueous or the molten form that conduct the electricity. Fine, so we know that these are only the two which can conduct electricity, one aqueous form and the other molten form. What are the anions and cations? Here you can see the anions negatively charged and cations positively charged ions which attracted toward the cathode. Here in this diagram you can see the cations, the positive one which are attracting toward cathode means negative electrode, and anion being negative ion attracting toward the anode, the positive one electrode. So next we are going to start the reactivity series. Here you can see from most to least reactive. There we actually discuss the ease of discharge. So if you will see for the metals, the ease of discharge would be of hydrogen. Fine, then that of all the metals which are given above from the hydrogen, like sodium, calcium and magnesium, aluminium, if coming in comparison with the hydrogen, so ease of discharge of hydrogen would be more than that of these metals. But if there are other metals like compound, ionic compound, molten or aqueous compound is containing the positive ion, copper or silver, so it means that ease of discharge of copper and silver and gold would be more than that of hydrogen. So this is the what reactivity series tells us about the ease of discharge. Here you can see the hydroxide ions have more ease of discharge, can easily be discharged than that of chlorine, bromine, sulfate and nitrate. Let's just start one by one. So here you can see the electrolysis of aqueous sodium chloride. Here you can see the electrolysis of aqueous sodium. In aqueous sodium chloride we have taken NaCl. So sodium being the positive ion means cations will attract toward the negative electrode, that is cathode, and chlorine being negative ion, anion, will attract toward the anode, positive electrode. What the reaction will happen, you can see here. On the previous slide we have seen that the positive and the negative ions will discharge according to the ease of discharge. Fine, so if we will compare sodium and hydrogen, so you can see here that sodium is present above in the reactivity series and hydrogen below in the reactivity series. So ease of discharge of hydrogen would be more than that of sodium. So it means that on cathode hydrogen will attract towards the cathode and will convert into hydrogen gas. How? The hydrogen ion will gain 4 electron and will convert into 2 mole of hydrogen gas. So hydrogen is less stable than sodium and hydrogen is selectively discharged. On the other side you can see that OH negative ions is less stable than chlorine, so that's why OH is the selective discharge of OH negative ions would be more than that of chlorine, and this is you have also seen in the previous slide. Here you can see the chlorine and OH negative, so discharge of OH negative would be more easy just because of less stable than that of chlorine. So here the equation is written in front of you, which you have already learned, how the hydroxide ion will be converted into 2 mole of water and 1 mole of oxygen by losing 4 electron, and this is the oxygen gas will liberate on anode, and on cathode hydrogen gas, and these are actually the product of electrolysis of aqueous sodium chloride. And the remaining solution from the both sides, the one of oxygen and the hydrogen, so the electrolyte solution will become more concentrated in sodium chloride. In other word, we can say that this is the electrolysis of water. In the same way you can see electrolysis of molten sodium chloride, where we have only in molten form we have only only specific those ions, that only the ions of that ionic, specifically ionic compound. So here we have only two ions, the one sodium and the other one chlorine. So you can see the both at anode, and what is happening at cathode. At anode oxidation, the chlorine ions by losing two electron will convert back again into chlorine gas and will liberate at anode. And here at cathode, reduction will occur, and you can see that sodium ions by gaining two electron will again convert into sodium metal and will deposit on this electrode cathode. Here you can see sodium is attracting toward cathode and chlorine gas is anode. Next, electrolysis of concentrated aqueous sodium chloride. Here aqueous one, and secondly concentrated. So whenever we are talking about concentrated, it means that we will prefer the release or the discharge of the ion of that specific anions of ionic compound. Fine, we will not see that according to ease of discharge. So you have already learnt about this. So chlorine is more simple than OH, so chlorine gas will evolve at anode, and hydrogen being less reactive, or they have ease of discharge would be more than that of sodium. So hydrogen will gas will liberate. So the same reaction will occur at anode and cathode, as you can see in this electrolysis. Next is the purification of copper. So how we can purify the coppers. Here you can see the one is impure anode, and anode that is made up of copper, and the other one is pure copper, that is actually your cathode. So here the reaction that is going on, you have also you know about this reaction. You learned regarding the purification of copper, how we can make them purify. Here you can see what will happen. The copper from anode, it will turn into copper 2 positive ion by losing 2 electron, and that copper 2 positive ions will attract toward the negative anode copper, which is made up of cathode, which is made up of copper, pure copper, and it start to deposit by again gaining 2 electron and will be converted into copper metal. In this way the anode will at the end gradually decrease in size, and cathode will increase in size, and the copper start to deposit on the cathode. Here you can see the electroplating, how we can electroplate any metal with any other metal. So here you have to make the anode actually that metal which you want to electroplate, and you have to place your object which you want to be plated. So here you can see the spoon, whether it's made up of silver or platinum or whatever, and let's suppose you want to make it plated with copper. So the result that which is occurring at anode and cathode, you can see it's written same you have seen on in the previous slide in electro that purification of copper. So what is simple cell? Simple cell, you can see here you have to actually you can check the voltmeter, the what is the voltage, and here the negative one electrode and the positive one. So the negative electrode should be of higher reactive metal, most reactive metal, and your positive electrode should be of least reactive metal, so that electrons can flow from higher to the lower one. And this in this you can see the voltage, and higher will be the voltage if higher the distance between the higher reactive metal to the least reactive metal, so more will be the voltage produced. So this is all about your preparation, some of the questions which could be in your quiz competition. So you have to prepare your quiz competition. It's all now the detail of simple cell is given here, that you have to maintain the you have to make this cell which actually convert the chemical energy into the electrical energy by using two different metals, and one should be higher reactive, other one should be the least reactive, and according to that voltage will produce. So thank you so much. Allah Hafiz.